So class, now we are going to study about 1.8 existing idea of a limit. I hope that you understand some part of the limit meanings from 1.7, but 1.8 we are going to go over again so that you understand a little bit better using different ways. So in appetizer part, I want you to think about this graph first, and I want you to pause it and think about when it's not continuous. When the graph not continuous, and then carefully answer A through J. It's okay to be wrong because that's why I keep putting those questions so that we can clearly understand what limit means. So please pause the video and then try to fill up the answer here. Fill up the answer here. And here's the answer. And check the answer with me. And now I'm going to explain quickly. So in here, negative 3 to the plus is heading to 4, and then negative 3 positive side also heading to 4. So both has a limit as a 4. Then I can say that limit exists at 4. However, the function is not continuous because we do not have a value at here. So this shows that not continuous. But this shows that has a limit exists. Another part that you have to be careful is going to be at 0. And that's the time you see it's not going to have limit exist. Also, if the limit doesn't exist, then you write it. If they're different, then it's limit do not exist. And other one is going to be fairly easy. I want to actually talk about this part. What if I said function, what is the limit of f over 4.5? What would that be? This one also you can say do not exist. Like a sine function, we talked about it. Sine function alternating up and down. So at 4.5, you can say that limit do not exist. Or if it's a really continuous, and then actually you can plug in and find that value, then that could be the answer. But in the big picture in this area, you could also say, I do not know which one it's going to be. So careful about that. So class, let's continue our appetizer of example 2. And we are going to study about next 2 questions again. This time I want to compare 1 over x squared minus 9 versus 1 over x squared plus 9. Seems like we saw something similar. So that's why it's going to be in class activities. I want to try. So how we graph this one? Actually, we did this graph long time ago. So let me just graph it for you quickly. So let's look at graph that I put it on here. Then let's answer. Also, if you want to see the work, we had it on 1.6. So just to go over one more time. The domain is going to be all real numbers, but 3 or negative 3. What will be the asymptote? Asymptote, vertical asymptote, horizontal asymptote, there are a bunch of them. So, as you see, my vertical asymptote is going to be x is equal to 3, y x is equal to negative 3. Horizontal asymptote is going to be y is equal to 0. Then, hold on right here. I'm going to introduce another way of finding horizontal asymptote. What does a horizontal asymptote means? Use the definition. Horizontal asymptote means x goes to infinity. And I want to see that where my graph ending to. So I'm going to put limit as x goes to infinity 1 over x squared minus 9. Just think about very abstract way. Infinity means the number very big. Number is going to be bigger than 1 million. So think about by plugging some numbers, can you guess how big this number is going to be? Because I'm going to do 1 over, let's plug in 1 million. Then 1 million squared will be 1, what is that? Trillion. So 1 trillion minus 9 is going to be still huge number. Almost like just a trillion. Then if you have 12 zeros, what is this number? 1 over about 9 less than trillion. Do you see that becomes 0.0000000000001? So if you have 1 over very big number, what is the illusion? It's gonna be heading to 0. So I'm showing you pre-cal way. Pre-calculus, you guys take the long division. Now I'm going to use limit definition. And what did I use? I have a rational function, and then this time I can plug in infinity, then I get 1 over infinity. What does that mean in calculus? 1 over big number means very small number, which is, I can say this is very close to 0. So that's another way now I want you to understand for calculus. So we check asymptote here. Then end behavior. Oh, that's the end behavior of the horizontal asymptote, right? End behavior of the horizontal asymptote. Then, Yona, what do you do about the vertical asymptote? Of course, we're going to use the same idea. In here, I will try to write vertical asymptote means here, when x goes to this time 3, right? And then my function is going to be 1 over x squared minus 9. But what happened? Can I plug in this number? No, I cannot, because that will make it 0. So I cannot actually plug in that number in this case. Then how are we going to observe? You have to plug in 2.9. That's how you're going to observe this number. That's probably we're going to come more in 2.1. So I'm going to wait for that time. So how do I know that my number is going to be really get smaller? Because I observe my graph. If I plug in limit as, let me use this color. Limit as 3 minus side, then what's gonna happen? My function goes to negative infinity. Then now I'm going to send x as 3 plus side. What happened here? That is going to be positive infinity. Then do I say my limit exists? No, limit do not exist. Then what happened? Limit do not exist, but one goes this direction, one goes the opposite direction. So, do you see that automatically there should have some sort of borderline between here that creates asymptote. Asymptote is a very hard definition to describe, but if you think about using limit, one graph goes to negative infinity, one goes to positive infinity, then there should have some sort of borderline between here. That is the asymptote of vertical. And that's a limit way of explaining asymptote. So we did some of the end behavior and then continuous. Is this function continuous? No, it's not continuous at 3 or negative 3. Not continuous. Then what is the limit at 1? Why is the limit at 1? Can I plug in 1 to find the limit? Yeah, because if you see this case, my function is continuous at 1, therefore I can actually just plug in, which will give me 1 over negative 8 as my limit. Okay, now your turn. I want to pause the video. We study about this one. I want you to relate it to the function of x squared plus 9, and then this function make all the reciprocal. That's the hint in order to graph this one, and then get some information and pause it, answer, and then compare the answer with me. Okay, class, we all mainly show the limit, so let's keep practice until you understand. I want you to look at the next graph, 2 over 3 x minus 3. Do you think you can graph this one? How about, do I know 1 over x graph? Then, do I know 2 over x stretch twice? And then, if I put x minus 3, do you see that I'm making right shifting transform right to the 3 units? So I'm going to use 1 over x graph, and 2 over x will make it a little bit sharper because you're stretching twice, and then move this one right 3. So you have your asymptote. My asymptote is going to be this 2, and then my point is going to passing through these coordinates. How do I know? Plug in. If you plug in 1, you get 2, right? So just plug in, that's why that's 2, and then that's my graph. So now I want you to looking at this one. Let's answer each limit questions. So when I have x goes to 3 to the positive, then what is my limit here? 3 from the right side, as I see my graph goes to infinity. If you look at next one, x is from 3 to the negative side, it goes to negative infinity. Then I want to talk about, what about limit at 3 then? What can I say? This case we say do not exist. But now you have to see what is this. This is the definition of a vertical asymptote using limits. How do I know that? 1 coming from right side 3 goes here, 1 coming from negative side of 3 here, and then 1 goes up and down. There should have invisible vertical line existing. So I want you to see that from here. When you're going to one number, but it goes to infinity, what does that mean? It becomes the definition of vertical asymptote with using limit. Now look at in-class activities. I want you to look at the graph and try to answer carefully. You can pause it. I'm just going to continue right away. This one is going to be 0 as x goes to infinity. My graph is follows, but never going to meet. Also, this left-hand side, negative infinity will be as a 0. So your graph is going to be keep following and then going to 0. That means, what does this mean? 1 from when I sending really far number is going to be stabilized around 1, around 0. When I'm sending very, very small number, also stabilizing around 0, then what does that mean? That will create little guideline of the horizontal asymptote. So you can see that this is horizontal asymptote definition. And whenever you do in-class activities, just pause so that you get to practice before you see my answers. Let's continue example 4. Let's continue example 4. I like to graph and then explain the behavior of a given function. So this time, the reason I'm doing it, we can also use calculus a little bit here. So one by one, let's answer here. The step there, how we graph this one is, first we are going to find the domain. So the domain is going to be all real numbers but negative 2. Then vertical asymptote. Vertical asymptote in calculus class and then pre-calculus class, they are slightly different. If you see the pre-calc class, you can actually compare your degree as this way. Then taking long division, 3x plus 4 divided by x plus 2 will be me. I'll be back. Okay, so vertical asymptote. In order to find vertical asymptote, you have to see your domain, and then your domain says I can have a negative 2, so you are going to have those guidelines of x is equal to negative 2. Next one will be horizontal asymptote. Horizontal asymptote is going to be in pre-calc, we are taking long divisions. So 3x plus 4 divided by x plus 2, you see the quotient as a 3. Then I can write it y equal to 3. But I want to show you now how do we do this one in calculus way. That means in order to find horizontal asymptote, we say that the x goes to infinity and 3x plus 4 over x plus 2, what happened? So if you plug in infinity, I'm going to get infinity over infinity. In mathematics, we cannot define that. We cannot say this is 1 because the other number can be twice bigger than the other infinity numbers. So how do we calculate that one? We are going to divide by the leading power. So all these 4 terms, I'm going to divide by x. So let me separate them. And I'm dividing by x, divide by x, divide by x, divide by x. Then still I'm sending limit as infinity. I want you to know this method because you will use that often, also AI project there. So when I plug in infinity, still now I can reduce this one as 3 plus 4 over x and then 1 plus 2 over x. What happened? Remember that 1 over infinity, what is this number? It becomes closer to 0. So I'm using the idea. When I look at 4 over infinity, this number will be very small as a 0. Same idea for the bottom. 2 over infinity, like 2 over 1 million, is very, very, very small number. So it gets 0. So it ended up with 3 over 1, which is a 3. Now this is a calculus way of finding limit. And that's what I get as horizontal asymptote. Now let's look at y-intercept. What will be y-intercept? Y-intercept means x is 0, so I'm going to plug in x is 0. I get as a 2. And then what is x-intercept? X-intercept means y is 0. So 4 plus 3x over x plus 2 is equal to 0. I'm going to calculate 0 over 1. Then I get 0 is equal to 4 plus 3x. 3x is equal to 4 negative 4. So I get x as a negative 4 over 3 as x-intercept. So negative 4 over 3, comma, 0. And then end behavior, also number 6, end behavior, and then any crossing points. So let me draw this one, and then we can probably conclude the number 6 part after seeing some graphs. Vertical asymptote at negative 2, horizontal asymptote at 3, and then y-intercept right here, x-intercept, negative 4 over 3 is 1.333 negative. So in this graph, also I need to see any function is gonna cross as a 3. So let's try to see if your function, is that going to be 3? Is there any x values? So let's try to compute quickly here. By cross multiply, I get 3x plus 4 is equal to 3x plus 6. If I cancel out, 4 is equal to 6. $4 and not $6. So there's no such x crossing the horizontal asymptote, so there's no crossing. That means my graph is almost done. This one has to be this shape, and then other side we have to plug in numbers. So I'm going to plug in negative 3 in order to see what we get. So if I plug in negative 3, that's going to be 4 minus 9 over negative 3 plus 2. That is going to be 5 over negative 1, so I get 5. And negative 3 comma 5 right here, I'm gonna have my graph. This is my graph. But the reason I want to show you in this part is we can also imply limit definition to find that. To find the horizontal asymptote. Okay. There's one question waiting right below. So I want to pause the video and then try in class activity 4. We're almost there, so keep trying. So class, let's look at in class activities graphs. Compare the 1 through 5, the informations, and then I got the graph, this shape, and I like to actually explain a couple of things. We need to talk about the limits since it's a calculus class, and I want to show you that how we're going to find the horizontal asymptote using limit here one more time. So when you look at this one, answer 2 to the negative side, 2 from the right side, it's going to positive infinity, which we actually say that do not exist. Yeah, if it goes infinity, then so from the negative 1, negative infinity, and then positive 1 will be positive infinity. So if limit goes to infinity, we usually say in calculus do not exist. I will just use as an infinity here, and for my class is okay, but when you do homework, make sure you write it as do not exist. And when you look at now x goes to infinity, you're talking about when x goes to infinity, what happened to my y value? My y value is going to be stabilized at 2. So this will be 2. What happened negative side? Also, it's going to stabilize at 2. So as you see, this will make a horizontal asymptote. If this goes side this way, this one this way, and stabilize at 2. So I want you to see that one. How do we find the horizontal asymptote using calculus? So limit as x goes to infinity. Then this function we can divide it by leading power. So I'm dividing by x all 4 terms. As you see, I divide by x here. And what happened? You can reduce your terms. I can reduce this one that I have a 2 plus 1 over x. Bottom has 1 minus 3 over x. Then using limit definition, 1 over means 1 over infinity is 0. Then what will be 1 over 0? That will be infinity. 1 over very small number becomes a very big number. So when you put this one, that gets close to 0. So my answer will be 2. That will be horizontal asymptote using calculus. Okay class, we are almost there. We are on dessert part of the 1.8 and we are going to talk about limit laws. So we saw that if it's a continuous, always we are going to have a limit exists. Oh, before that I want to actually ask about, do we have a limit of a cosine function? Is there a limit in cosine function as x goes to infinity? If x goes to infinity, then we cannot say if the limit exists. So if I say careful, if limit x goes to infinity and sine x, then this is going to be do not exist, because either it can be 1 or 0 or -1. It's gonna be up and down. Then so class, let's look at the dessert part of it today. We are almost done. We are going to review, we are going to study about limit laws. But before we do, I want to review about what is the limit of the sine function. What is the limit of the sine function? Depending on the question here, that's why you have to be careful. Limit as x goes to infinity, your sine function is actually do not exist. But what if I have sine as x goes to 0? Do I have a limit at that time? This one, yes, we will have 0 as answer. How about if I put limit x as a pi, x goes to pi, what would that be? Also, that is gonna go to 0, because within the domain, every sine function is continuous. So don't forget this concept here of the sine function. Then today, very end, we are going to talk about the limit laws briefly, and then we do one more question, we'll be done. So in the limit, always your limit has to have a, hopefully, it doesn't have to be continuous function, but if there are two limit function exist, then you can actually use like algebra. So I want you to look at here, we can add those two limits, we can also subtract those two limits, we can also multiply by a number, and then multiply each other. Also, we can divide. So they have a same operation like algebra. Just so you know that denominator cannot be 0. So if you have two limits, you can just use operation like algebra. So that's today's one of the main part of the topic. So I want you to now continue in class activities. Again, now in class activity 5 and 6, these are the questions we actually saw it, because we are going to build this one a little bit bigger on chapter 2 that I want you to actually understand clearly doing one more time. So pause the video, try in class activities 5 and 6, both of them, so that you can compare the answer with me, and good luck. Okay class, we are on the last in class activities of the dessert part. So let's compare the last two questions. Activity 5 came from 1.7 and activity 6 came from 1.3, and we are going to use these ones in the future. So let's keep studying. So when I look at this, without this one, I hope that you guys figured. You can see either my answer will be 1 or -1, but now I have 2 that I can rewrite it this way. My number is bigger than 3, then my absolute value is going to be always positive, so I can cancel out, and it's going to be 2 for the graph of a piecewise function. And then when x is less than 3, then my number of the absolute value, you have to bring it out with a negative, because you have to force to make positive. Which means if you plug in 0, then it's a -3, but it has to be 3. So that negative will make a positive number. When you plug in 0, 0 minus 3, so 3. That is the absolute value of the definition there. So I can reduce it, this one again, so I get -2. So my graph will have either 2 or -2 as my range. Then using the graph, carefully answer, and hopefully you got this same answer with me. And in class activity 6, this one, I want you to keep trying until you get it, because later, next section, we are going to take a limit from here. So we are going to send in limit h as 0 for the 1.9. So make sure before we do 1.9, you guys understand rate of change. So my answer is 3 over the denominator. And then if you didn't get it, make sure check yours with mine, and usually there's a negative mistake. So that's it for today, and great job everybody, and I will see you next class. Bye.